Live in 3, 2, 1.
Hi, welcome to SparkFun Live. I'm Toni.
And I'm Mike.
Today, we're here to help you win a little love on this upcoming Valentine's Day with your very own custom pickup line generator.
We've built ours into this soft, cuddly, and non-threatening sock monkey toy, but we'll show you how to put together the electronics so that you can embed it in any kind of object you want.
Today, I'm going to be working on the hardware circuit with you guys, and Mike over here is going to walk you through the code. So if at any point you guys have questions or need clarification on something, please post in the comments, and we will have those relayed to us by our awesome support team here, and we can try and figure that out for you. Also, if you guys are looking for the code for this or the wish list for parts, if you haven't picked those up yet, check in the description below where
Down
Mike
here.
is pointing. Yes, below us. So. Yeah, I guess we can get started. In case you guys didn't see the demo video, this is what the monkey sounds like when he talks. So in case you couldn't understand that, he says, "Are you an ionized halogen? Because I'm only seeing the positive side of you." Not exactly the most classic pickup line, but again, you know, it depends on your audience. You guys can customize these for whoever you plan on using them on. All right. So, first of all, if you guys can look at the GitHub repo that we have the code and the fritzing diagram showing you exactly how to wire the circuit up. Mike has that pulled up on his computer screen right now, and you guys should be seeing that hopefully. The repository also has, if you could switch to the fritzing link. So the fritzing link here, this is going to be the circuit we're putting together today. So you guys can see we've got an Arduino Uno in here, we've got the voice box shield, and then this is just general parts, so you can customize these, but we've got a speaker over here and then a standard power supply. You guys could be using different parts at home, so you may not be using a Pro Mini. We went with the Pro Mini just to keep it really small form factor to put it inside the monkey. But you could use this with a standard Arduino Uno or any other board that you wanted. You also could be using a different speaker. In the monkey here, we have the really big speaker, as I wire him up. This is the 25 watt, 8 ohm speaker that we carry, but unfortunately this has been out of stock for a while, so if you guys weren't able to get your hands on one of those, today we're going to be using this little speaker, which is, I believe, an 1/8 ohm.
Something like that.
Yeah, something.
Still well small enough that it's not going to be damaged by the voice box shield.
And it's a little bit quieter, so obviously keep that in mind depending on what you're embedding this in. Mike, if you were going to embed this in something, what would you put it in?
I'd have to say I'd probably put it into a stuffed companion cube from the game Portal.
All right, well there you go. So if you guys are ready, I think what we're going to do now is we're going to make sure we have all of our tools together. So you're going to want your soldering iron, some wires, wire cutters, scissors if you need those, your ever handy multimeter. And you're also going to want to make sure you have your computer set up for the code.
We've got a little FTDI basic tied up here so that we can upload the code to our Arduino Pro Mini board. We'll be using Arduino 1.0.5. That is the latest non-beta release. We strongly suggest that you go with that because the 1.5 releases sometimes have some bugs and don't work exactly the way you might expect them to. And while you're at it, why don't you go ahead and take a look at the GitHub repository, the link again down here. You can download the zip file of the repository and save the code into your directory of choice so that you can look at it in the Arduino IDE a little bit later once we start talking about the code.
All right. So while you guys are getting that set up, we're going to start soldering some bits and pieces together here. So what I've done is I just snapped off some headers. I'm going to solder those onto the bottom of the Pro Mini so that way we have a nice programming port, so that way later when we go to upload our code with the FTDI board, we can do that. So I'm going to get those soldered on here. Got my handy dandy soldering iron and some solder right here, and we'll get that going. And for those of you who have shaky hands like me, sometimes things like a third hand really help for this, so that's something to consider if you're just watching this video and thinking about doing this project later on. You might want to consider picking one of those up.
And for those of you without shaky hands, a few cups of coffee will help you with that.
All right, so now we've got our awesome little programming header on there. Now what we're going to do is we're going to start wiring up the shield over here to the Pro Mini. As you can see on the fritzing diagram here, which you might want to pull up on yours, we've got all of these pins over here on the right side of the shield, or left side I guess for you guys. Pins 5 through 12 are all wired to ground. That's because the shield actually, you can use those pins for different functionality, but for the way we have the code written right now, you don't need to input anything to those pins or use those for running the chip, so we don't need to have those. So we're just going to have those pulled low. So, all right, and what I'm going to do is I'm going to take my shield now, and we've got some pre-cut wires, so this might take you guys a little bit longer at home, but don't worry, you can always watch this again after it's done, and you know, any steps that you've missed, you can go back through and redo them then. So what we're going to do is we're just going to kind of hack this together and just pull all of these pins. We're going to tie them all together and then tie that to ground when we solder them. If you guys are running this on an Arduino Uno, you can actually set that up in the code and pull those pins, set those pins low in the code, so you don't have to worry about doing that hardware-wise. You can do that on the software side of things. Go through here.
While Tony's doing that, I do just want to mention that even if you downloaded the GitHub code a little while ago, it's probably best to go ahead and make sure that you download it again right now, because we pushed some last-minute changes right before we started broadcasting. So if you want to make sure that you've got the most up-to-date version of the code, go ahead and grab that now.
And again, you guys can be putting this into any enclosure you wanted. So, you know, this is, we're hacking this together one way to keep this as small as we can to go in here, but you could also, if you're feeling really motivated, get the SpeakJet chip on your own, which is this little chip on here, if you guys can see that. I don't know what camera it's on. And then you can wire this up independently on a breadboard if you wanted. So that's also something to keep in mind.
The more e-textiles inclined persons may wish to try using LilyPad Arduinos or LilyPad products for this. That'll work just fine. If that's the sort of thing you're into, you probably already know how to make a circuit, translate a circuit over into LilyPad world. But it's certainly an option as well.
And for those of you who do use the e-textiles, make sure if you are embedding this on some kind of cute little fuzzy critter, you're not using conductive thread to sew it all up, because that will actually short things out. And then you have a smoking monkey, which we did actually have happen when we were building the prototype for this. So nobody wants to see a sad monkey on fire. All right.
You guys remember the little smoking monkey toys that you could get? Does anybody remember that, or is that just me? Little thing. Yeah, out of vending machines.
There were smoking monkeys and vending machines, Mike?
There were smoking monkeys. And they were like, you know, an inch tall, and you put a little thing in their mouth. I don't know, I never bought one, but I remember seeing it at the airport when I was a kid.
You know some weird stuff.
Yeah.
This is definitely a part you want to make sure you don't burn yourself on, so be careful there. Again, that comes back to that shaking hands thing. So, you know, less coffee, or, you know, having a friendly person that you don't mind burning, that they can hold all the components for you. But we don't recommend that. It doesn't really make you friends. All right.
And I'm going to take the opportunity to say that if you find soldering difficult and you are using lead-free solder, buy some leaded solder. It is the best thing you will ever invest money in as far as improving your soldering.
All right. So we've got all of our pins now soldered together here with that little piece of wire running through them. Now I just gotta run a little jumper between pin 12 and ground here on the shield. So that's what we're gonna do next here. Make sure when you do this though that you don't solder anything to that pin 13 connection. We actually need that as the input into the Arduino. So as you can see again on the fritzing diagram, we've got that pin 13 from the shield connected to the Arduino. So that is actually an important pin for the voice box shield to run properly. So make sure you don't accidentally short this on there, because that's not gonna work well then. There we go. And also you guys, if you're doing this at home and you're not working along with us currently and you're just planning on doing this later on your own, you can also, space this out a little bit better and see exactly how much wire connection you're going to need, especially for your custom enclosure. So we're going to have everything kind of compact, but you could definitely have the button spread out farther. For example, on our monkey here, we have the button all the way down in his arm. So there's a lot more wire there than we have between the other bits and pieces. So keep that in mind too as you're laying out your circuit. What is that old phrase? Measure twice, cut once, something like that?
Measure, yes.
Yes.
Yeah.
All right. So measure twice, cut once. That's our suggestion for the day. And again, if you guys have any questions for us, please feel free to post them on the side. All right.
We could also share some other pieces of folksy wisdom.
Please do.
See a pin and pick it up, and then all day long you'll have a pin. That's one I like.
A pin or a
pin?
pen?
Pin.
Oh, okay.
Yes. Pin.
All right. That's a new one. I've never heard that.
Yeah.
All right. So now for this next part, we want to use our button here. Just to add a little stability for ours, we also are using the LED RGB button breakout, or they're not RGB, excuse me, that's a misspeak. We're using that on here just so we can have a nice strong connection for the wires to be connected to when we solder these. You do not have to do this. So again, this is very customizable. If you wanted to build this with a bigger button, you could also do that. So that's, again, just something to keep in mind. You don't necessarily need to do that, but that's what we're doing here. So what we're going to do is we're going to take our little push button and we're going to insert it on the board. And you're going to have 2 extra holes on here because this is just a standard push button. It doesn't have the LED in it. So you're going to have these 2 open pins here. If you did happen to get one of the LED push buttons, then obviously those will be hooked up, and then you can actually, you'll have to wire in additional circuitry so that way you can actually light up the LED. So got that button in there. Now I'm going to solder this guy together. Again, trying to balance this so that way it doesn't shake so much for you guys. Also a good time to mention, if you guys don't solder all that often, you generally want to do this in a well-ventilated space so that way you're not sucking up these fumes and then getting confused and using your random pickup line generator on the wrong kind of person.
Known to the state of California to cause cancer.
Also true.
Yes.
All right.
So if you don't live in California, it's not really a problem.
Legally. Still probably not something you want to be sniffing, so just to cover us, you know. All right. So now that we've got that hooked up there, again, we're only going to be using 2 of these pins on this breakout board since we don't have the LED in the button, in the push button. So we're not going to pay any attention to these pins that are labeled C and A, but B1 and B2, those are our button leads basically. So what happens is when we push the push button, it actually ends up shorting those 2 pins together. So what we're going to do now is we're going to wire it up like we have shown in the fritzing diagram with our 10K resistor here. Super small, so hopefully you guys can see that on the camera. If you want, you can use this awesome prototyping space that's available on the Shield, and you can actually add this in there, so that does save you a little bit of wiring space. So something to think about, again, when you're laying out your circuit. So that's what we're going to do on here. We're going to add this guy on, and then we're going to run our jumper wires to this. So we've put the resistor through 2 of those holes, and now we're going to flip it over, bent the legs, and then we're going to add a little bit of solder. And again, make sure you don't burn yourself, because resistor legs are very good at conducting heat. When you go to clip these now, you don't want to clip them super short, because you are going to have to jumper these to the pins next to them in order to connect them to the wires that we have. Since this is prototyping space, all of these holes are separate, so just keep that in mind. If you're using one of our new small breadboards, those do have the pins connected in the rows, so that's something you could use that and save yourself a little bit of effort there, but again, very customizable depending on what you're doing. So.
You'll also note Toni being very careful to hold on to the leads as she clips them so that they don't shoot off and poke somebody's eye out.
However, you could live dangerously and not, and just let them fly where they might, so it takes all types. All right. So now what we're going to do here, we want to run one of our resistors. We've got the resistor connected to the button and also to pin 5 on the Arduino, so we're going to have to run a jumper wire between those 2. So we're going to assume that our button is going to be over here, so we're going to actually do this with a little bit of wire spacing so that way you guys can see what's going on. So we're going to run jumper wire through there, and then we want to run this right here. So again, flip these over, have the wires bent so it makes it a little easier to solder them. Again, this is where having a third hand would be really useful, so hey, look at Mike being such a good third hand. Now if I can do this without burning him.
Hot. Oh, it's hot.
We let it go. And in today's lesson on electricity, metal conducts heat. There we go. This one's good, I think.
Okay.
Yeah, don't hurt yourself there. All right. So you can see I didn't actually jumper these 2 pins quite yet because I still have to run one more jumper wire from the Shield to our Arduino. So now that we have the button and the resistor will be connected, and then also connect those to the Arduino. And now we're going to clip these guys again without shooting them off. One of our tech support folks, who's very helpful, actually uses the little leads coming off of the resistors and the wires and all that, and actually makes tiny little sculptures out of them as well. So if you're really into recycling every bit and piece of a project, you can always save those bits and parts and make tiny little sculptures to go with your pickup line generator in case it doesn't work so well. So
it's Valentine's presents for your hopefully successful date acquisition.
All right, so now we're going to get another wire here, run that through. Okay. Again, our magic support team has brought us a third hand, so we can actually use that. Which I'm not going to use right now, so. So again, I'm going to solder this wire in here, and then I'm going to jumper that resistor, which is right there, and then that additional wire that's running to the button right here, and we're going to solder all of those together. Yeah. All right. Nice big blob of solder there. Since we don't have any other components around it, we don't have to worry about that shorting out, but if you're working with a bunch of additional sensors and trying to add in other stuff to this prototyping space, make sure you don't end up shorting something that you don't want connected.
Again, a reminder, anybody who has comments or questions they'd like to have addressed on air, you can go ahead and type those into the sidebar. And we've got somebody waiting just off screen anxiously to hand those off to us so that we can deal with them.
All right, and then this other wire that we have there, we're now going to connect this to pin 5 on our Arduino. So make sure when you look at this, you actually find digital pin 5, not analog pin 5, because otherwise, if you're not coding it correctly, it won't read anything. So I'm going to connect that in there.
So we've had a question, somebody asking how long it'll run on one AAA battery. It actually won't run on one AAA battery unless you use some sort of a step-up voltage supply, and I would guess at that point that it's not going to run terribly long on one AAA. You're going to want to use at least, I would say, 3 AAAs or 3 AA batteries, but I would guess that on 3 AAs or even 3 AAAs, you're looking at several hours. I mean, you know, you take this puppy out to the bars one evening and you are good to go.
All right. So, let's see, what's our next step here? All right, so then that last leg of the resistor, we actually want to tie that to ground here, as we've got that showing on the fritzing diagram on the shield. So we're going to use a little jumper wire here to do that. And let's see, what's the best way we can do that? So, this wire is actually much too long for what we need, so to make it a little bit easier on myself, I'm going to cut this down to a better length for this. Use our handy dandy wire strippers, always good to have when you're doing something like this. And oops. And it's still a little too long, so I'm going to cut it just a little bit shorter. And sometimes, if you really can't get a good grip on the wire when you're trying to strip it, using additional tools can help. There we go. Right. A little bit more soldering here, and again, I want that jumper wire that I just put in there, I want to connect that to those other pins I just made. So I'm just going to add that blob of solder there and just kind of short them out. If you're planning on doing this and embedding it in something that's going to get really, really hot, you might want to take that into consideration when wiring it up. You don't want to have giant blobs of solder that could potentially melt and then end up losing your connections, though I don't know what kind of enclosure you could use for that to get it that hot. So
Toaster oven?
yeah, I feel like carrying around a toaster oven to pick people up might be a little difficult.
It is a conversation starter.
That is true. I would have to question why someone was carrying a toaster oven around with them everywhere, especially if they weren't making, you know, waffles or something delicious. All right. So now that we've got that on there, we want to connect the next side of our button. So this, hold that so it's proper for you guys. So with that B1, we have B2 connected here. Remember, that's connecting to our resistor, and then it's also tied to ground and to pin 5 on our Arduino. So now we're going to connect the other side of the button, so that way when we push it, it'll end up shorting them, but we're going to connect the B1 to VCC in this case, which is going to be 5 volts. So we're going to do that now. So, and we have it wired, so it just, on the fritzing diagram, it's just kind of showing a connection into a 5-volt line. There's a lot of different ways you can do that. You can run your Arduino, the 5 volts between your Arduino and your shield, and then run a jumper wire from the shields over to the prototyping area, or however you want to do it. So again, there's different ways you can run this to customize it. It's up to you guys. So, and I think while we're doing that, we're going to actually run And this wire should be long enough. There we go. And we want to find VCC on our Arduino here. This one, you do need to use a 5-volt Arduino to run the shield properly, so the 3.3 volt Pro Mini wouldn't work. That's really the only power stipulation for the shield. So like Mike was saying, if you wanted to use some kind of different battery pack or something, you'd have to use a regulator. Up. All right. And now, so I've got the 5 volts pin on the shield connected to the 5 volt VCC line on our Arduino. So now what we're going to do is we're going to run a little jumper wire from that 5 volts to the button over here, so that way we can have those both connected. And I realize I connected up a wire wrong. All right. Mike, while I'm doing this, do you want to explain the FTDI drivers that people will need for
That's actually a very good idea, Toni. So because we're using a Pro Mini, we needed to use an FTDI basic to get this connected. The FTDI drivers that are required for that, the FTDI basic board, which has a little serial to USB bridge on it, those drivers are actually in the Arduino installation folder. There's a drivers folder in there that you can use to load the drivers for this board. Otherwise, you can always download them from ftdichip.com. If you have trouble getting your drivers installed, which some people have under the later versions of Windows and Mac OS, you could go to our website and look for the tutorial where we have some helpful advice on getting your Arduino drivers installed. How's the chip coming, Toni?
It's coming pretty good. So what I'm doing right now is I'm shorting or connecting the wire from our button to our shield. And I'm actually connecting that to the 5 volt line. So what you guys can see here, I did connect it through the 3.3 volt pin, which is fine on this because we're not connected to an Arduino Uno. However, if you were running this off of an Uno, you wouldn't be able to do that. If you look at the schematic for the shield, that 3.3 volt pin simply acts as a pass-through in case you decided to stack any other shields on top of this one. So it doesn't actually connect to anything on the voice box chip, or the SpeakJet chip, excuse me. Another option for customization, which we're not going to do today, but you guys can check out on the website, there's also the text-to-speech chip which we carry, which if you could pull that up, we can show them that. You can actually use that to make this sound to where you can actually type in commands or type in sentences to the chip to make it a little bit easier than the way you have to code this now, which Mike will be showing you guys in a few minutes. So, all right. And again, I'm just going to do a visual check, make sure I didn't end up shorting VCC and ground together. Again, we don't want to catch our poor monkey or any other cute little furry, non-threatening looking items on fire. So,
we've had a question. Somebody's asking whether there's a way to change the voice that the chip uses to read off the phrases. There's not a voice per se. You can mess with the pitch controls and make the voice sound different, but If you are familiar with the old Macintosh speak commands that they had, I don't know if they still do. I haven't used a Mac in far too long. But the old text-to-speech that the old Macs had where they had different voices that you could select, there's nothing like that. But you can play with the pitch and the speed and things like that to make your voice sound slightly different and unusual.
Yes. All right, so now what I'm doing is I'm running wire between pin 13 on the shield to Arduino pin 13. We need to get those connected. So I'm getting those in there.
Pin 13 is the ready pin on the SpeakJet shield. That will send a signal back to the Arduino letting it know that the SpeakJet is ready to accept signals, ready to accept commands from the Arduino.
All right. Solder that on there. And I just realized I forgot to solder my button connection over here that I added, so I'm going to do that. Make sure I don't short that out. Soldering one is getting pretty hot. Clipping these extra leads here. I want to be really careful because it looks like I've got my button leads are a little close. Don't want those shorting out, so I'm going to try and clip that even shorter to make sure they're not connected at all. Especially if you're going to be embedding this in something like the monkey arm or your own stuffed animal type arm. Make sure that you have really good connections on those buttons. As you're trying to shove it down the arm, it can disconnect things, and then you can be sitting there pressing it not knowing why your circuit's not working. So, all right, and let's see. So now what we're going to do is we're going to go through and we're going to wire up pins 2, 3, and 4 on the shield to the corresponding pins on the Arduino board. So pin 2 connects to pin 2, pin 3 to pin 3, and pin 4 to pin 4. And while I'm doing that, maybe you want to start showing the code and getting the code pulled up and how it's working.
So we have our code downloaded from GitHub and loaded up into Arduino 1.0.5. The code itself is divided into two files. There's one called pickup_generator.ino, and then there's a pickuplines.h file. The pickuplines.h file is the actual phrases that we are going to use, that the SpeakJet will output as we trigger it. And the pickupgenerator.ino file is the sketch that will control the output and trigger it when you push the button. We've got the software serial to send the commands over a serial port line to the SpeakJet. All of our commands are going to go over serial communications for this. And we're using software serial rather than the built-in serial port, because if we were to use the built-in serial port, that's kind of a pain to try programming as you're iterating over the inevitable process of burning and debugging your program. We also include pickup lines h.h and avr/programspace.h. We'll tell you in a little while there what those are being used for. We have some pin numbers defined on here. We have the ready pin defined to be connected to pin 13. That is the pin that, as I mentioned earlier, lets the Arduino know that the SpeakJet board is ready to accept commands. We have a reset pin, which is connected to the reset line on the SpeakJet board, and that allows you to reset the SpeakJet board to its default power-up status. Sometimes that's a useful thing to do right at the beginning of your sketch. And we have the SPK line, which comes back from the SpeakJet to let you know when something is happening on the SpeakJet. We also have the TX pin defined, which is going to be the transmit pin used in our software serial. We have the button pin defined to be digital input number 5, and we've got a button state, which is a holder variable for us to track whether the input pin for the button has been pressed or not. The next step we're going to create a software serial port that we call SpeakJet, and we're going to tie that to pins 0 and to TX pin. It doesn't really matter where we tie the receive pin to, which is to pin 0, because we're not going to use that one and no data is going to flow across it. We're also going to attach to the TX pin, where we define that up above, to pin 2, so we'll tell it to attach the TX pin to pin 2. In our setup, we have to configure pins for our SpeakJet module. So we want to configure the TX pin to be an output to send data to the SpeakJet module. SPK is an input to receive signals from the SpeakJet module. Button pin is an input to receive signals from the button. We then need to configure our serial port to communicate to the SpeakJet module. So we'll set that up to be at 9600 BPS, which is the standard data rate for the SpeakJet module. And then we're going to send to the SpeakJet module this command to set the volume to the maximum setting, because you don't want your pickup lines to be misunderstood or missed entirely in a noisy bar.
All right. And if you were using this on an Arduino Uno, those pins that we all shorted together and tied to ground, this would be the place in your code where you would actually set those as low. So that way they were tied software-wise to ground. So that way you're not using them. And if you guys want to see an example of that, you can actually find that example code on the VoiceBox Shield page. So you can check that out later after we're done with this. So, all right. And this is almost ready to go, except I realized that in the process of showing you guys how to do this, I accidentally connected my ground line between my resistor and my button to the wrong spot. So I'm going to fix that here. So that's basically a quick and easy fix. I'm just going to trim this wire right there. And again, I got to do this because otherwise, if we don't fix that resistor now, what will happen is it can actually end up shorting the board. Without that resistor, you can end up shorting VCC to ground through the button, and then you fry all of your components, and that is no good. So, but quick, easy fix. Again, this is a really good step, a good point to show or to remind you all that you should always check your circuits before you solder, just like you should measure twice before you cut, and also double check everything before you add power, the last step. So.
Okay, well, Tony's working on that. We'll go through a little bit more of the code and explain it. Again, we're going to kind of go line by line and explain what everything's doing as it goes through. The next thing, after we've set up our software serial and set the volume to the maximum setting on the SpeakJet board, we're going to set up the onboard hardware serial from the Arduino and set that up again at 9600 baud, just because that's a nice speed that we like, and we'll use that to send some debugging data back to the computer as we're trying to figure out why our code is or is not working. We'll make the ready pin an input so that we can read back the status of the SpeakJet, and we'll make the reset pin an output. Once we've finished all of that, we're going to set the reset pin to low, which will reset the SpeakJet module. We'll delay for 100 milliseconds to give the SpeakJet module a little bit of time to actually complete its reset. And then we're going to set the reset pin back to high so that it can get back to active. We'll print out the serial port. Just a little note to ourselves saying that we've reset the SpeakJet, and that lets us know that we've made it this far in the code without having anything go wrong yet. Once we get into the loop, we're going to read the button state of that pin, that button that we put in there. We're going to write that to the button state variable that we created up above, Then we're going to print the value of that button state out to the serial port. Again, just kind of as a sanity check that we know that things are going the way we think they should be going. That way, if you press the button and nothing happens, you can find whether or not it's a failure of the button signal to be read properly, or if it's something else causing the failure. We have a couple of buffers here that we're going to read strings out of the program memory and into RAM, and then we're going to write those out the serial port to the SpeakJet, which will cause it to output the speech, the lines that we're interested in.
Yes.
Yeah.
All right. Going to quickly interject here. We finally got everything between the Arduino, the shield, and the button hooked up, so now it's time to hook up our speaker. This little speaker here, you can see we've got 2 tabs here, and if you look really closely, you can see that one is labeled as a plus, one is labeled as a minus. That corresponds to the labels on the SpeakJet shield where it says speak plus, speak minus. So that means speaker plus and speaker minus. So you just want to keep an eye on those when you're wiring them up. One thing to note, if you wanted to, you guys can use something like female headers on your shield and then just run jumper wires from your speaker into that, so you can plug it in and remove it later if you think you might want to switch the speaker out for a different one, such as this bigger guy here. You can see on this speaker we have 2 header pins that were soldered to it, so that way we can use jumper wires when we hook it up. So just again, another point where you can customize your setup to work for you. So I'm going to solder, we're just going to solder some basic wires on here just to get this going so you guys can see it, but again, just keep that in mind that there is an option for that. Also, if you are using this particular speaker, just be really careful with these tabs so you don't rip them off. If you rip them off, you're not going to be able to connect your speaker very easily without some serious soldering to fix it, so just keep that in mind. So I'm going to actually bend those out a little bit. This gets a little hard because the tools stick to the speaker since it's magnetic.
I also want to mention here, if you want to, you can certainly attach an amplifier to this board between the speaker and the board and the SpeakJet. The SpeakJet's, it can be a little bit quiet. The output of it can be a little bit on the quiet side. So if you want to hook up a mono amp to it, that's perfectly acceptable, and it'll give you a little bit more bang for your buck.
Mm-hmm. Have these wires go the same way, so that way don't have strain on them. You can move it around as needed. And of course, we do keep referring to this as a pickup line generator, but keep in mind you can always use this for any kind of random automation of sound. So for example, if you happen to have another big sporting event coming up that you're a fan of in the next few weeks and want to build a random taunt generator, you can do that for the opposing team. You could also, if you need a random encouragement thing for your office, or a joke generator.
Random conversation topics.
Mm-hmm.
The Civil War was neither civil nor was it a war. Discuss.
So, all right, and then again, we're gonna cut off any of that excess wire so we don't have things shorting out later. Alright, so now we've got our speaker soldered up. So now we're going to connect this to the shield. Again, we're going to check that positive going to the positive and the negative going to the negative. So make sure you have those on the right spot. And my wires are a different length, which is silly. So I'm going to change that. Strip these wires down. Strip that a little bit further. Alright. All right. These guys. And the final assembly step, now that we have everything together, we've got our nice little push button, we've got our speaker here. Alternatively, if you wanted to, you could also be using headphones. There's a nice headphone jack on the Shield, so keep that in mind if you can somehow convince people that you don't know to put on headphones. You could alternatively do that, which helps with the noise. But again, that's another option. And the last step here is we're going to hook up our battery pack to our system and provide power. So right here we've got the 4-pack for the 1.5 volt AA batteries here. I'm going to put these all in here and get this soldered up to the board. And what we're going to do is I'm going to solder those, I'm going to connect this onto the Arduino, the VCC and the ground pins. Alternatively, again, this is another place where you could use headers, for example, to plug that in. So, for example, on this one that we have, that was our demo, we wanted to be able to pull the batteries in and out so that way the batteries wouldn't die for this. So we just soldered little headers to those wires there so we can just plug everything in. And that is the VoiceBox Shield telling you that the ready pin was initialized. So.
All right.
All right. Now the next step after we get this connected is going to be coding.
Yes. We've been looking over the code a little bit up till this point. So now we've gotten actually to the point in the loop where we are waiting for the button to go high. A word on this, the way this is wired in the example diagram is a pull down. So when you push the button, it will pull the button signal high. That way, when you're looking at the signal, you can see that we're doing a button state equals high logic rather than button state equals low. Either of those is a way to do it. You can set it up however you feel most comfortable. Then within our if button state equals high logic, we are first using the random seed function to seed the random number generator with the noise that is currently on the floating analog 0 line. Since analog 0 is not tied to anything, the analog input on that is going to just kind of dance around according to whatever the phase of the moon, sunspot activity, local paranormal activity, you know, what have you. And since that's kind of a non-deterministic thing, by doing a random seed on that analog value, you get a little bit better guarantee that the circuit is not going to, or the code is not going to behave the same way every time you boot it up. The next thing we're doing, we're generating a random number, random 0 to 7, and that's going to pick out one of the pickup lines that we have. Then we have the string copy p function, strcpy underscore capital P, buffer 1. Excuse me. That goes to the program memory, the flash memory space in the chip where we have stored the strings that we want our SpeakJet to read. The reason we do that is because those strings take up a lot of memory, and if you were to initialize them into the fairly limited system memory that the Arduino has on boot, you would very quickly find yourself overwriting the entire system memory that's available, and that would cause your program to do all kinds of weird, flaky things that would be really hard for you to ultimately debug. So then we go to the next stage, speakjet.print buffer 1. We're writing the data out of that buffer and then delaying for 3,000 milliseconds, 3 seconds, to give it time to read that out. We've timed our pickup lines so that each one of those strings is less than 3 seconds long. We go to the next step. We do another random seed on analog A1, same sort of deal. Another random number that we generate, and we pull another one from the flash memory because we're taking our pickup lines are taking the Are you a blank because you blank format? So we have questions and answers. We have a question table and an answer table. The second part is the answer table. We're kind of randomly mixing matching them because that adds a surrealist edge to the entire experience.
You don't have to do this, obviously. You could have it say one complete actual pickup line the whole time, but then it wouldn't be random quite so much. So we really like random things around here.
Yes. So I mentioned earlier that all of the pickup line sequences are stored in flash memory. That flash memory is defined in this pickuplines.h file. And it's defined as these strings of 8-bit values. So you can see in here, we've got just kind of these long, seemingly random almost strings of numbers. In order to interpret what those do, you're going to have to get into the user's manual for the SpeakJet chip a little bit. And in the user's manual, there's a command set for lines that can be sent over the serial port. And each one of those commands will cause the SpeakJet to do something slightly different. The SpeakJet is based entirely on creating phonemes one at a time and then stitching those phonemes together rather than trying to say a word. So you don't say, tell it to say hello, you tell it to say ha, eh, l, o. And each one of those different phonemes has got a different 8-bit code associated with it. So on page 16 of the data sheet, there's an entire list of all of the various phonemes that you can have it say, along with example words that it will use, and the amount of time that it takes for each one of those phonemes to be pronounced. Back to page 15, there's actually some options for doing longer or shorter pauses, for playing the next sound faster or slower than you would normally want it to, for rising or lowering tones, so that you can give your word, your speech, a more, well, insofar as it's possible, you can give it a more natural sound. The strings, to convert the string into a the string that you desire it to say into a string of phonemes is kind of an arduous process. We've gone through. Toni assures me it takes hours to do this.
Yes, the 7 pickup lines we have, I think it took me about 4.5 hours to go through, because especially as Mike said, you can slow down syllables, speed them up, and that really changes the sound of some words. So
right.
It's a lot of practice.
And not only that, but you're not considering the spelling of the word, you're considering the phonetic sound of the word, and so you're thinking effectively in a completely different alphabet than you normally would be. But of course, all of these things are detailed in the data sheet, pages 15 and 16. You can find the link to the data sheet on the VoiceBox Shield website, or the VoiceBox Shield page on our website. You're looking for the SpeakJet User's Guide. There's also a SpeakJet Dictionary option, which is simply a text document which has all of those sounds and functions laid out in it for reference, easy reference.
So now we've got our little battery connector soldered up here, and I put in our batteries. You want to make sure that when you do this, you double check that you've got the proper orientation of all your batteries, since they alternate, so you've got positive and negative, and then positive, negative. You really want to make sure you have those hooked into your battery pack correctly, because otherwise, if you plug this in backwards, you again end up frying your circuit. And after all this hard work we've done, we don't want to do that. So what we're going to have to do now, though, is we need to program the system, because if we powered it right now, it's not going to do anything. So we're going to get that programmed here on the computer with that code that Mike just went through for you guys, as soon as he's done fixing his microphone issues that we're having here. So sometimes being live is just really hard.
Live TV, folks.
Yep. This is SparkFun right here. This is what we do. So it's very exciting. Microphone changes.
Just gonna go.
There you go. All right. So Mike, I'm going to give you the circuit here to get it powered up, and I'm going to move
So,
the
as I
monkey.
mentioned earlier, we've got an FTDI basic going here. We don't need to necessarily worry right now about having the battery pack attached to the circuit, because the circuit is small enough that we can power it over the FTDI basic connection through the USB port. So I'm going to go ahead and plug that on and make very sure that I am not plugging it in backwards. And I hear a little bit of talking there. I'm not sure.
Yep. And
So.
that could also be because there is a volume control on the shield here. So what we want to do is we want to turn that up and try not to short everything out while doing it. These potentiometers are really, really delicate, so be very careful when you're doing this so you don't rip it off.
She says, going after it with a pair of pliers.
So, yeah. All right.
So now that we have everything hooked up, we've got it connected up to our computer here. We'll go into the tools menu as we normally do for selecting an Arduino sketch, and we will select the board type, which in our case is an Arduino Pro/Pro Mini 5-volt 16 megahertz with Atmega 328. And we're going to select the serial port that it's connected to. In my case, it's COM38, but yours, of course, is going to be different. And hit upload. So you'll see it's compiling the sketch. Binary sketch size about 7 kilobytes, not that large. Done uploading.
We got all our happy blinking lights on there.
We've got happy blinky lights.
Let's see if it works. And this, again, this is very quiet, so it might be that our volume is not turned up quite a bit. This is also going to be something you want to play with your, depending on if you get a different speaker or how you have this set up. You could also hook this up with a sound transducer if you wanted to, for example, embed this in like a wooden box or something.
Yes, the surface transducer, great fun. Particularly entertaining to hide in people's desks or offices.
How would you know
Why is my
that?
potted plant speaking to me?
Mm-hmm. Oh, come on. Let's see.
So if we can take a look at what's going on my monitor here, we'll see that the debugging print statement that we set up in the code is telling us over and over and over again that button state is equal to 1. So that means that there is probably something amok with the button pull up, pull down circuitry. So Toni's going to take a look at that and see if she can get that working. We've got a question from the audience. Is there a way to silence the ready when it turns on? That's a great question that I'm going to have to honestly say I do not know the answer to. I suspect that there is a way to do this. There is an EEPROM on board the SpeakJet chip, which has things that can be set. And I'm looking, and it says address 237, power up reset phrase, bit 7, play equals 0, silence equals 1. So you can go ahead and silence that easily enough by writing to the EEPROM. There's some example code on the SparkFun website that'll show you how to do that. And that...
There we go. Oop. So yeah, the reason that we weren't hearing any of the volume is the volume dial was turned all the way down. So And again, you can see pliers are not really the great way to go about this with this potentiometer. It's kind of eating it up a little bit. This works really well with a pair of those, for example, eyeglass screwdrivers. You can change this a lot better with those. So get that turn. All right. All right.
Ready.
So now you said there was a short somewhere, or it's reading high?
Well, yeah, it's telling me that it's high.
Alright, so that means that we need to figure out what is shorting out on our circuit.
And I'll look at the code and see if there might be something wrong in the code that's causing that to...
And you know what I bet it is? It's probably these wires that I forgot to cut right there.
There
And
you go.
again, always make sure you trim your excess wires. Shorts are never your friend.
I kind of like shorts in the summer.
Yeah. Shorts in the, alright, fair enough. Clothing shorts are good.
Yeah.
Electronic shorts, not so good. Get those
All right, let's see what we got going here.
trimmed down a little bit further. And
Okay, we're still reading.
high, yeah. Something was shorting out on that.
Oh, we've got
Make sure we wired all of our buttons. Oh, hey, look at that
Nice little
screwdriver.
screwdriver.
There we go. Thanks to our friendly crew here. So you can see, yep.
Kind of makes you wonder what else they'll bring us, doesn't it?
Maybe
We
that,
ask for a koala bear.
that would be amazing. We really need a koala bear, guys.
Yeah.
That's the only thing that will make this work.
Run on, go on, get us a koala bear.
So I'm not seeing any obvious shorts on here, so it's time to bust out the handy multimeter that we brought along. And we'll just set this to see if we've got shorts anywhere. Guessing it might be somewhere with this button.
Want to just
Yeah,
disconnect the power before we
that's-
do that?
Yep. So make sure all of our connections. So that's a good sign there.
Yeah.
Are we-
Confusingly, of course, there are good shorts and bad shorts.
Yep. If we expect something to be connected and it doesn't say it is, that's a bad thing. So, looks like our resistor's set up okay. It's tied to ground. Make sure our ground and VCC over here aren't shorting. And dice on that. Is it something on the button? No, it could be.
Doesn't look like it.
Hmm. Let's see. Flip this guy over so I can test on the back here. Just make sure we could have a bad button, but
Oh,
doesn't look like
I
it.
wonder if I see what's going on here. There. It's pulled low.
Oh. Can you click that button for me while I test this? There we go. So we can tell our button is working
Button's
properly.
good. Let's just check the logic here. Okay, so we've got ground to the
Mhm.
resistor. The resistor is tied to the button.
Pin
The-
5 of the Arduino, and also to the button.
And then
The other line of the button is connected to 5 volts.
yeah, so when you, so that's actually not going to pull that down.
It should be.
No, because you've got you're connecting 5 volts across the resistor, and the resistor can't pull down.
Well, looks like we've got another question coming up here. Let me see. So I think that's what we did on the first one.
That's actually, if you look at your,
Oh, did I maybe? I might have wired that up incorrectly on that. Let me double check what I did on here.
And ladies and gentlemen, we have been given a koala bear.
Oh, lovely.
It's cute. He looks sad.
Can you show the koala bear there?
Koala bear, right there.
Yeah. All right.
So what I discovered here,
Yep.
what we've discovered is, if we can look on here,
Yeah.
when
You can show it on the computer.
I
Oh
suppose.
yeah. You can throw
So
that on there.
when Toni connected this up, she had intended to have this resistor hook through here to ground, so that when the switch is open, the line is being pulled to ground through that resistor.
Yep.
And then when you push the button, it connects that to the 5-volt line, which then pulls that line high to 5 volts. What actually happened,
Yeah.
if I'm getting this right,
In
is
your head. Yeah.
that she has this turd tied to the 5 volts
Mhm.
and this over here tied to ground through the resistor. So when the button gets closed, it connects the pin here to the 5-volt to ground through the 5 volts, and effectively is just causing a current to flow through that resistor, but the voltage is not actually going to drop.
And this is what happens when you hurry up and try and make your fritzing diagram before your Monday morning meeting without you having coffee. So apologies to all of you for that. We will get that fixed and up on the website momentarily as soon as we're done here. And in the meantime, we can fix that on the resistor on here. But again, where I have it wired up correctly on this guy, which is why when we plug this one in, again, and we've got that ready again, which you can, as Mike discovered, silence. Oh, hey. Yeah. So, that one. So basically what we're going to have to do on this is a little bit of rework. Again, it's going to be cutting those wires and just rerunning them. That's the nice thing about having this prototyping space. We can always do that. And yeah.
We can also cheat a little bit by using the internal pull-up resistors and changing the code a little bit, kind of on the fly here.
If you want to do that, we could do that as well. Might be fun to show people.
So, sure.
All right.
So in that case, all we're going to need to do for the switch here, the switch will just disconnect that entirely.
Ah, yes.
We're going to cut those wires
Yep.
out. Make sure that I don't cut anything that I don't need to cut.
Yeah.
That needs to be cut.
There you go. You should do
and
that
then
under
this
the.
one is, let's see.
There you go.
So then this one right here
So
is
Mike just disconnected that wire that we had going to B1 there.
right. And then I'm going to cut this wire right here. And what we're going to do, instead of having the external pull-up resistor, we're going to go ahead and, excuse my reach, we'll strip the ends. And we're just going to connect one of these to pin, I'm actually going to use pin 7. Oh no, wait, we
Nope.
can't use pin 7.
Nope.
So
So we can, well, we
Which one of
can,
these can we use
because
that's
remember,
not,
we want to connect them on the Arduino. These are just shorted on the
yes,
shield.
Good point.
So.
Good point. Okay, so we will. We're going to connect it actually over here to pins, pin 7 and ground.
Right. Now we'll get those
Toni,
started.
since Toni's on the soldering iron side, I'll pass that over to her. There is nothing to ruin a working relationship like trying to solder it across somebody's lap.
And you said you wanted pin 7 there, right, Mike?
Pin 7, yeah, pin 7 is
All right.
perfect.
So while I'm doing this, what are you going to be doing to the code?
So, we can take a look at our code over here, and we're going to have to make a couple of changes. The first change is in our defines up above where we have button pin. We had it set to button pin 5. We're going to change that to button pin 7. This is why we actually use defines in code, is because if you need to make a change like this, you only change it in one location, and then it propagates everywhere through the code where that symbol gets used, and then you don't accidentally miss one and find yourself introducing a bug someplace into your code. Further down here, we have the pin mode function, the pin mode setup. In the setup function, we have pin mode button pin input. On the newer versions of Arduino, you can make that input underscore pull up, and that will cause the internal pull up resistor to be activated. And then on the older versions of Arduino, rather than doing that, you have to do the pin mode input, and then you have to do a digital write button pin high. That will also activate the internal pull-up. I'm going to go ahead and write in the button pin high pull-up mode of doing this, because that is more backwards compatible and more people are familiar with it than using the input underscore pull-up method. The last thing that we're going to need to do, you'll remember down here, we were checking to see if button state equals high, then we go into our speak loop. We don't want to do that now because we're using the internal pull-up resistor. Now, when you push the button, that button pin input is going to go low. So we need to change if button state equals high to if button state equals low. And now that we've made those few changes to the code, we can go ahead and re-upload this to our Arduino, now that Toni has finished making the changes to the hardware.
And just a side note, I also cut off the extra wire we had running from the prototyping area to the pin 5 on the Arduino, so that way, just to clean it up a little bit, we don't have extra wires in there and don't accidentally make another mistake like that.
Okay, again. Okay, we got our little ready croak from the board, which means our power is all hooked up right. We're going to go ahead and upload our sketch.
We're getting our happy little lights on our Arduino here, or our FTDI board, showing that it's uploading the code.
Okay, it says done uploading. I'm going to open up the serial monitor and... success. So it is, according to the serial monitor, the button read is going through properly. However, we're still not hearing it read out the strings from the Arduino. So this is the next step. That's why it's good that we've put this this serial loop check in here for writing the value out. That's giving us our check on where we know that that is triggering, that it's going into that loop, that the button is hooked up properly, that everything else is working. It's just that we've got this one little thing of, well, why is this not connecting? Why is it not triggering speech on the SpeakJet board?
So one of the things to keep in mind with this, this chip is really finicky depending on the length of the phrases that you give it. So that was also something, when I was originally writing up the pickup lines, we had to go through and change a few of the wonderful pickup lines that the employees here at SparkFun gathered together for us. Some of them were simply too long of a phrase and the chip would not be able to handle it coming in. So as Mike said earlier, that's why we added in that delay of 3,000 milliseconds between each of the phrases. So this could be potentially just something that it's generating a random number where it's then pulling two phrases that it can't handle saying together. So we do have the volume loud enough so when we reset the system, I don't know if you guys can hear that, but if we hit reset, there's a little bit of noise there. So it is communicating. So could just be something like that that's going on. This chip is definitely one that you want to take your time working with and be patient because it can be really frustrating. So, and Mike is changing all sorts of things in the code here.
I'm going to go ahead and add in another check just to see what numbers we're reading when we get these that random number. I want to know what number gets generated so that I can see whether or not that's within a reasonable bound for the numbers for the array of sentences that have been programmed in here. Toni mentioned that when she was working with this, when she was originally developing, there was some odd behavior from the random number generation functions, and so that kind of says to me the first place to look is at that random number generation and see if there's something fishy going on there. So we'll see what that does as we upload that code.
Yep. And if you guys want to look more into the random number generator issue, this is well documented with the Arduino in the forum and on their libraries. There's a user in the community, I can't remember the name off the top of my head, but they've written up a really great true random generator library, so you guys can find that with a quick Google search and download that. You can also see why, the detailed explanation as to why a random number generator isn't actually random on the Arduino. So, what did you find with your check, Mike?
What I discovered is this is actually very much what you saw when you were originally developing. I'm asking it for a random number, and rather than giving me an actual honest-to-goodness random number, although I guess it is for certain values of random, it's just returning 0 every time. Random 1, 0. Random 2, 0. And that doesn't mesh with any of the things that we can look for in our list of random numbers, or random phrases.
And this also, did you change it to where it wasn't reading the analog pin?
Yeah, I wonder if doing that, does that improve matters some?
It can. So that's also part of it as well. That's something you guys can change and customize on your own circuits. So the way we had it originally, the analog read random, or the generation of the random number from the analog input, because that analog pin isn't connected to anything, it's just basically reading noise. If you wanted to have it actually change the variation every time, you could hook up some kind of sensor. So you could have a pressure sensor on there, or some kind of light sensor, or even a temperature sensor. So depending on how hot or cold the person is you're trying to use this with, you could actually have a different pickup line generated depending on that.
So now we're getting acceptable random values, but we're still not getting a sound out of there.
And that might be the chip too. Let's see. Nothing is shorting out, so the chip should be working. Just double check that we have all those other pins pulled low and that they're connected to ground. Because again, those pins do have different functionality depending on what you're using them for. Well, that's weird. All right. So with that obnoxious beeping, we know that we have all of those pins tied to ground, which is good. My guess is this is still probably code-based with the random number generator from the trouble I had with this initially when we were putting it together. We might need to play around with that a bit more. Can also try using the example phrases that they have on the code as well. Oh, you got rid of those, so.
Of course I did.
Yeah. So if you guys actually look at the example sketch on the VoiceBox Shield, you can always try uploading that. The baud rate, we had a question just come in from the forums, or the comments asking if it could possibly be the baud rate. That's certainly something to check. This does, however, work fine at 9600, so unless that somehow got changed in our code between upload, that shouldn't be the problem. But that is always a good thing to check on your code, especially if you're playing around with this. You can also change the baud rate on the SpeakJet chip. So if you guys have to use this in a different different setting, or you're trying to use the shield with something else where that baud rate does need to change, that is something you can take into consideration. So Mike has pulled up here on his computer the example code from the SpeakJet or the VoiceBox Shield page. So you can always check that as well. Try loading that code up to see if there could be some problems with if it's a circuit problem or if it's your code. So there's different ways you can troubleshoot that. So we can keep digging into this, and if we do find a fix for the code, we will get that uploaded to GitHub for you guys, along with the fixed fritzing diagram. So, have any other last minute things there, Mike?
No last minute advice for getting this working.
Yeah.
Certainly we will dig into this a little bit and see if we can figure out exactly where it's gone wrong. This, of course, is not entirely like a cooking show. We don't have a magic oven that we can pull a finished cooked turkey out of to show you what the final example looks like.
Can promise it did work.
It does work.
It does work. This is one of those joys of electronics where sometimes you have to debug stuff, and of course we can probably spend a bunch of time out doing this, but we don't want to waste your guys' time, well, for those of you watching this live. But thank you for tuning in, and we will see you guys next time on SparkFun Live.
Bye!
Live in 3, 2, 1.